In this video, we're going to be talking about half equations, but we just need to finish off those two questions from the last video. So your equation is balanced, so we can get straight into it. So we've got sodium hydroxide, aqueous solution, so it will separate into our sodium ion and our hydroxide ion, and our nitric acid in aqueous solution, hydrogen ion, and our nitrate ion. And then this sodium nitrate, also aqueous, will give us Na plus AQ plus NO3 minus AQ. Now our water, that's a covalently bonded compound and it's in liquid, so it is H2O liquid. Now, if we look at what the spectator ions are, on both sides I've got Na plus, and on both sides I've got nitrate. So, if I write out my final equation, what I have is OH minus AQ plus H plus AQ gives me H2O liquid. And that is a neutralization reaction. So any neutralization reaction, that's what's really happening. Because up here, what have I got? I've got an alkali, and I've got an acid, and this is a salt, and this is water. So that's your standard alkali plus acid gives you salt and water. What's really happening is you get your hydroxide ion and your hydrogen ion, and they combine together to give you water. Okay, right, on to the next one. So for this one, it did need balancing. You needed to add a 2 here. Your barium chloride separates, your sodium sulfate separates. Now, your barium sulfate is a solid, okay, so that's a precipitate. So that cannot be separated into ions. So that just stays as BaSO4 solid. Now this is aqueous, so it will separate, and it will separate into 2Na plus 2Cl minus. Okay, and now we can go through and see what are our spectator ions. We've got our sodiums, and we've got our chlorines, and then we can write out our as Ba2 plus SO42 minus will give us BaSO4 solid. Okay, hopefully you got those right. If not, you might want to pause it now, make a few corrections, make sure you know where you went wrong. All right, so moving on. We're now going to look at half equations. All right, so this is the ionic equation for the reaction between sodium and an acid. Okay, so if you to go back in your notes, you can find one of those. You've got an example of that somewhere. The ionic equation turns out to just be this. Now we can separate this into two halves. So if we look at what happens to the sodium first, we have 2Na solid goes to make 2Na plus aqueous. And if we look at what happens to our hydrogen ion, it is 2H plus AQ goes to make H2 gas. So, how does this happen? Well, in order for sodium to become sodium plus, if we think right back to the start of this, for sodium to become sodium plus, what does it do? It loses an electron. Okay? So what's happening is, I have my sodium, and then that separates into a sodium ion and an electron. However, I've got 2 sodium ions, so that's going to give I've got 2 sodium atoms to give 2 sodium ions and 2 electrons. Okay? What happens to these 2 electrons? Well, in order to go from a positive ion to a neutral ion, I need to gain electrons. So these are gained down here. So my positive plus my negative gives me my neutral hydrogen molecule. Now, these have special names. So this reaction here, this is called oxidation, right over here. And this is called reduction. Okay, and the way you remember it is, you know that oxidation is loss. Okay, so in oxidation I'm losing the electron, and reduction, here I'm gaining the electron, reduction is gain. So I have oil rig. Oxidation is loss, reduction is gain. Okay, so what I'd like you to do now is you can pause the video and just do these two for me. Okay, so you should have had my magnesium is becoming Mg2+, and in order to do that, it's going to need to, well, it's gone from neutral to positive, so it's going to need to have lost 2 electrons, and my 2H+ is making H2 gas, so I've got 2 positive charges, because each hydrogen ion is a +1 charge, but I've got 2 of them, so in order to do that, I'm going to need to gain 2 electrons. Okay, and again, this is oxidation, and this is reduction. And for the last one, you should have 2 lithiums becomes 2 lithium plus. Okay, and again, each lithium ion is 1+, but I've got 2 of them, so it's 2E-. And I've got 2H+, gives me my hydrogen molecule here. And also go from my positive to my neutral, I need to have gained 2 electrons, and again, that's oxidation, and that's reduction. Okay, nice and easy. All right, now, finally, last little bit, I just want to have a look at these questions here. So what I've got here is I've given you the half equations, and you need to combine these to write the ionic equation. So what am I talking about? Over here, I gave you the ionic equation, and you had to write the 2 half equations. Now I'm going to give you the half equations, and you need to write the ionic equation. Very simple. So all we do is we take everything on the left-hand side and add it together, everything on the right-hand side and add it together. It's a little bit like simultaneous equations. So on the left-hand side, I've got Fe solid, that's that one, plus 2H plus Aq, that's that one, plus 2E minus, that's that one, is going to make Fe2 plus Aq, that one, plus 2E minus, that's that one, plus H2 gas, that one. And now we can look at it, and again, anything that you see on both sides of the equation, you can get rid of. So we don't need the electrons anymore, and we have just iron plus 2H plus Aq will give us Fe2 plus Aq plus H2 gas. Okay, and what's that? That is iron reacting with an acid to form a dissolved ionic compound and hydrogen gas. Okay, so whenever you see this here, whenever you see this 2H plus, you should be thinking, acid. Okay, because acids will always dissociate to provide H plus ions. All right, and finally, you can have a go at this one, so pause the video now and have a go at that one. Okay, so same again, Sr solid plus 2H plus 2E minus gives us SR2 plus AQ plus 2E minus plus H2 gas. Electrons are on both sides, get rid of those. I have SR solid plus 2H plus AQ gives me SR2 plus AQ plus H2 gas. And we are all done. Good work.